Welcome to MathGPT. Today, we'll be learning how to balance a chemical equation step by step to ensure the conservation of mass. We'll be focusing on the reaction between KNO3 and H2CO3 to form K2CO3 and HNO3. Let's get started. Here we have an unbalanced chemical equation. Before we start balancing it, let's write down what we have on both sides of the equation. On the left side, we have potassium nitrate, KNO3, and carbonic acid, H2CO3. On the right side, we have potassium carbonate, K2CO3, and nitric acid, HNO3. When balancing a chemical equation, our goal is to make sure the number of each type of atom on the reactant side is equal to the number on the product side. Let's start with potassium, which we abbreviate as K. On the left side, we have one potassium atom from KNO3, but on the right side, we have two potassium atoms from K2CO3. Let's balance potassium by adding a coefficient of 2 in front of KNO3. Notice that we now have two atoms of potassium on each side. Now, let's look at nitrogen. We have two nitrogen atoms on the left side because of the added coefficient, and two on the right from the two nitric acid molecules in the products. Oxygen is balanced too, with 6 on each side. So we are good here. Now on to carbon. We have one carbon on the reactant side from H2CO3 and one carbon on the product side. So carbon is balanced. Finally, we have hydrogen. There are two hydrogen atoms in the reactant side and only one on the product side. We can balance this by adding a coefficient of 2 in front of HNO3. And now we have balanced the equation. Every type of atom has the same count on both sides, maintaining the conservation of mass. In conclusion, this was a double replacement reaction where potassium ions swapped with hydrogen ions in the presence of carbonate, forming potassium carbonate and nitric acid. Balancing the coefficients ensures that we comply with the law of conservation of mass, which states that matter cannot be created or destroyed.